Jason, meet Jason. Hey, this is Jason, our flagship test user. So we're building mind-controlled robotic arms.
All the problems I was having with my prosthetics, they were already thinking about and addressing.
So the goal for today is to find out whether this works, whether it all comes together and behaves exactly the way we planned.
The opportunities are endless that I see here. We're just scratching the surface of what's there now. And I think that there's going to be opportunities all over in how we replace parts of the body for either better life or extended life.
Man's age-old dream of flight becomes a reality.
1, 0, all engines running. Hippity hopping along.
Welcome to Eric's crib.
This is the MTV Funhouse. One big playground for us. Honestly, I will say that. And then to us, this is just one big lab. Like that was the idea.
My name is Tyler Hayes. I'm co-founder and CEO here at Atom Limbs, and at Atom Limbs, we are making artificial limbs. For the most part, what that actually means is we're basically making mind-controlled robotic arms that people can wear.
My name is Doug Satsker. I am the Chief Design Officer for Atom Limbs. My role at Atom Limbs is a connection to the person, the human, understanding human factors, the biology, the people, and the aesthetic and the appearance of how people engage or interact with the arm. In '96, Apple called me and asked me to come back out. My role at Apple was in the design group as a designer, but my focus was on all color, all materials, and all finishes from a design perspective. Early '97, Steve Jobs came back, and the design team became his closest relationship at Apple. And it was probably the best working relation because his honesty and being so direct, there's no sort of other agenda. Steve is always about get the work done, do the right thing.
I grew up as the infinitely curious kid. I was a kid who took everything apart. You know, if I got bought a toy for Christmas, the next morning it was taken apart, that kind of thing. And I always had this dream of something I designed or something I built being in someone's hand. That led me to Apple and a very long career developing consumer products. And mainly the products I've worked on have been mobile. They're in people's hands. You have to wear them or carry about them. Atom Limbs is just really a continuation of that. And I'm still learning here at Atom Limbs.
My background before Atom Limbs has been a career of 20 years in the technology industry. And I moved out to San Francisco after I graduated college, and in college I studied psychology, wanted to be a psychologist or a neurosurgeon. So I have a deep appreciation for neuroscience. As I've spent in the last 20 years, about 10 years in the healthcare industry now.
The idea of delivering a solution for such an underserved community, I couldn't imagine where I could take my career and my experiences and my resources to add to that opportunity to build something this great.
Yeah, so who are Atom Limbs for? Atom Limbs are primarily for people who've lost their limbs. So these are people who've gone through trauma, who've lived through cancer, maybe had diabetes, and they've lost part or all of their arm. So it might be your hand, it might be below your elbow, it might be your full arm all the way up to your shoulder. So the two biggest barriers for people today is one, that the arms don't do that much, and two, that they're unaffordable. So what we're doing for people is pretty simple. We're making an arm that is not only breakthrough capability, so there's more functionality, you can control more parts of the arm, you have more degrees of freedom, more range of motion, it's lighter, it's easier to wear. It's also more affordable than these state-of-the-art myoelectric arms today, which are typically around $200,000. So we're aiming for a price point that's much, much lower, basically an order of magnitude lower, so around $25,000, which is the price of a hook arm that someone would get today. So because no one can afford these today, no company is willing to put in the R&D bill to actually develop a better product. What we basically decided was, we don't care, we're just gonna do it anyway. And the hypothesis here is, well, if you can make something that everyone can use, rather than just less than 5% of people, now you can get real scale, which means you can bring the cost down, you bring the price down.
The solution that you get today is sort of cobbled together by a bunch of different folks. There's no single person accountable or single entity accountable for the final product solution. Put it all under one roof, get it to the point where you actually hit the tipping point of scale, And the costs become pretty straightforward for us, and it's still, you know, a reasonably profitable business and all that. It's not a money play for us. This is an impact project, obviously. Each of the subsystems we're developing here at Atom Limbs, be it the wearable, the control system, or the actuators, need a deep level of refinement. You'll see a lot of examples of prosthetic hands and arms on YouTube that are great endeavors, but they don't have the level of refinement that's necessary to achieve the speed.
So we designed everything you see in the arm, whether it's the actuators, the interconnect, the actual assembly itself. So what that means is we can effectively sort of remove any part of the arm and it can still function the rest of it. So if we wanted to make a hand today, what would we have to do? We would have to develop not the actual actuators themselves, those are done, not the neural interface, that's done, not the attachment fully, because we already have this shirt that we've designed, that we'd have to modify it for something like a forearm. It really comes down to where do you put the power and how do you make it lightweight and comfortable all day.
We have three big challenges here at Atom Limbs. First, we have to design a product that is wearable, is comfortable on the human body all day. The second is we have to make it small and lightweight. We have to develop actuators that fit in the form factor of a human hand. That's just something that just hasn't been done before. And we have to control it. We have to control it in a way that's very natural, very usable to an amputee. Kind of want to have a one-does-all product.
It's typical to have a system attached to your body with compression and a strap that goes across your chest. Most people who have been wearing them, that use them, can wear them for about 2 hours. Our goal is to say 4 is a limit, 6 is best, 8 would be amazing, right? To get as comfortable in a system that would allow you to rebalance your body and have a system that you can wear all day.
All right, let's go meet Jason. Hello. So Jason, meet Jason. Hey, this is Jason, our flagship test user.
Hey, how are you doing? My name's Jason Morris. I was born in Michigan, but I've lived here in California for the last 40 years. I became an amputee in 2012 from a work accident, and I'm here at Atom Limbs now, and we're just testing out the greatest of technologies.
What we do is we sense muscle activity on the skin of the user, and that is known as EMG or surface EMG. We translate those EMG patterns through machine learning into commands that command our actuators. Those actuators can be grouped as one command, like a hand close, or can be an individual actuator. It's really up to the user on how that's programmed. So what we do is we take muscle activity, convert it to commands. We call those users commands. And then there's a control system that runs each actuator. And that control system can interpret those commands and output those as motion for the user. Now, there's a little bit more to it than that. The user also needs feedback. The user can see typically what their hand is doing, but the user needs a sense of touch. So we have force sensing resistors on each of the fingertips, so the user can sense if they're touching or gripping something. We have macros built in that are like grip mode, things like that keep the grip sticky. So the control system in bare bones is a EMG in and actuation out, but there's a lot more to that in closing the loop, if you will. And that's kind of our secret sauce. This is like a 10-year leap that we condensed down into maybe 2 or 3. And now we have that ability to optimize, I'd say, on the typical 4 to 6 week sprint that you see. And today you're seeing a 3-week sprint. This is some stuff that's commercially available, and we developed our own. This is just kind of showing you a little bit of an evolution, and this is it integrated into what we call the cuff. But the real trick is you got to integrate this cuff into the socket.
We started with sensors on a band to allow us to get it on. We did these here were sort of moisture tests to see if moisture on your skin would cross different sensor points. We started building these inside for us to see how to get it integrated into a system on your arm with as many as 16. But most recently we built these cuffs, have compression in them, so they're more comfortable.
This can be used to operate a virtual version of our arm. So instead of this being integrated into a socket, a user could take this home and practice on what might look like a video game experience, basically a virtual arm, 3D arm.
And because of the flexibility of the socket, that flexibility allows us to either build it into the system, or what we're doing right now is to have a cuff on the arm first, and then when it's on the arm it goes in here, and then Jason will tighten this down to the compression he likes,
All the problems I was having with my prosthetics, they were already thinking about and addressing. It was really exciting to me to see that. And then I walked over and looked at the arm, and they're showing me the fingers. I'm like, wow, this hand looks so natural compared to what's out there in the public. I really was excited to see that they're working on independent finger control. The wrist moved in more than just a rotational pattern. And these are all things I'm like, I wish they had in current prosthetics, and they just didn't. To have all this integrated into one arm and not having 15 different companies building your one arm that have to integrate it together, that becomes frustration on my as an end user. So they're working on integrating all that into one arm, and it's just gonna, I think it's working together because so far with all the testing I've gone through, it's just been amazing, and to see the progression.
It's a product that scales with the skill of the user. So as a user improves, their experience improves as well. I wouldn't call it a learning curve as much as I call it like stepping into more features. Like if you buy an iPhone, you might use only a few apps the first time, and you might be using 20 apps in a couple weeks. Very similar. We treat this as a lessons learned exercise every time a user comes in. So we will sit down, evaluate the performance, we'll evaluate the video that we took, and we will decide like what are the next steps that we want to take in either speed, functionality that we want to add. We've architected for far more functionality than you see in these videos today, a lot more. And so it's what do we integrate in what order? What's the right order of execution, if you will, as we progress? And I think we're kind of now at the point where the technology's proven. Now it's about optimization, about refinement. And again, that's what makes products great. There are a lot of great products out there, but what makes them great is the level of refinement. It's the people and their passion.
If you want to get the best people in the world, you really just need to pick the most challenging problem for the most part. You know, the most talented people in the world want to work on the hardest problems in the world. And it was kind of a wake-up call for me as a CEO. You know, it was my third or fourth time doing this. And, you know, there's a lot of people who have a lot of talent who could spend a lot of their time at a lot of really amazing companies. So what would make them want to join this? And it was really the mission, which kind of led to the second thing I've learned, which is you can't move fast and break things when you're dealing with limbs that you put on people. And there's a certain speed you can run at, for sure. But I think what I learned is that it's less about speed and it's more about communication. And I think a lot of us have heard this, but it's really become acute over the last few years, what it means to plan, to organize, to strategize ahead of time when you have to deal with a massive amount of change from actuators to code to soft goods. You kind of can't just do this stuff on the fly. You really do have to plan it ahead of time. And fortunately, we have an amazing team who's done this, you know, for decades that's able to pull that off.
Every time a user uses our product, it makes my hair stand up, straight up. Some folks have never even experienced this type of motion or control. So it's even more special when a user walks in kind of on the blind, like just having no idea what myoelectric control is capable of doing, going through some simple training in maybe 5 or 10 minutes and fitting them up and actually having use of a limb again that's a non-ordinary experience.
I think the thing that excites me the most about the future is we're going to deliver solutions for more and more amputees, or more and more opportunities for human-worn robotics. We've started with one of the hardest things, transhumeral, and as we present it to you, we're looking at below elbow and partial hand. Additionally, we'll get into legs, but then also there's going to be a point where we have to go invasive, where we actually have direct connection from the arm.
At the end of the day, what matters the most is seeing smiles on people's faces. I think that people who've lost their limbs or were born with limb difference, for basically all of human history, have never had a moment where they thought we could actually potentially restore, you know, a lot of, if not all of, what we've lost. And we're not there yet. But I think that's our mission. That's what we got to do over the next 10 to 20 years, you know? Immediately over the next 6 to 12 months, what matters the most to us is, one, clinical trials. So we want to show insurers that this is a, you know, efficacious product. 2, FDA authorization. Prosthetics do require FDA clearance. And 3, beyond that, just going to market. We have just over 11,000 people on our wait list right now who are pre-registered to buy one of these arms. And we just immediately want to be getting these to them as fast as possible. You know, they've been waiting for a couple of years. They've largely lived their lives without these for, you know, decades sometimes.
We're just scratching the surface of what's there now. And I think that there's going to be opportunities all over in how we replace parts of the body for either a better life or extended life. And I think that better life is the initial. It's like, how do I get to a point where I can be more like I was? Or when people were born without a limb, how do they get to a point where they first time be able to use things? And that's even more exciting. So even though they haven't trained or they don't have any just neuropaths that have been trained over a period of time, like an amputee, surprisingly, we're seeing them have the opportunity to actually use it.
When they call me and they tell me, they're like, hey, we want you to come up and do some testing for their arm, I get all giddy and excited because I love coming up here and seeing the advancements. I love working with all these guys around here. They're just, everybody in my eyes is a genius here, and they're at the top of the level on every field, and see them working and making their advancements, and it's been wonderful.